Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 87. In the last video we saw cursors. In this diagram you can see list, queue, set. These three are a child interface of collection. We already discussed list interface and their implementation classes. Now let's discuss queue interface. So what is a queue? Queue interface is a child interface of collection. It introduced in a Java 1.5 version. We already know whole collection framework introduced in a Java 1.2, but this queue part introduced later 1.5 version. Queue interface order element in a FIFO manner, first in first out manner. In a FIFO, first element get first chance and last element get a last chance. In this example, you can see in a queue first person get a first chance and last person get a last chance. Here one by one person get a chance in a queue wise. If you talk a real life example, if you want to get a ticket, if you want to collect, if you want to do some reservation, then we have to stand queue. We have to stand in a queue and there get a chance one by one. Okay, first person get, then second person, then third person. In this way get a chance. Here we have some implementation classes and interfaces, so let's discuss one by one. First we discuss a priority queue. This one is a class. Queue follow first in first out manner, but sometimes we need to process object in a queue based on a priority. In this case we can use a priority queue. Queue simply follow first in first out manner, but I have some requirement. I want to process data priority wise. In that case I'll simply use a priority queue. Priority queue, all element value store in a some order. It's a default ascending order. Here we can store duplicate, but here we can't store a null value because here comparison required for storing order, some order. For storing ascending order, here required a comparison. Here first element compare with the second element, and if we store a null value, then it will throw the null point exception. Here you can see example. My senior member already assigned me 4 tasks. Okay, I have a total 5 tasks. My senior member assigned me 4 tasks. Those are 4 tasks is a regular development task, those low priority tasks. Then suddenly he assigned a one more task, that is a high priority task that actually impacting a customer. Okay, that's why this one is a high priority task. Okay, then I want to put this all task in a Excel. I put those all tasks in a priority wise. I'll put first high priority, then put low priority task. Okay, in this case only the insertion time store element in the priority wise or ascending order wise. Inserting those tasks in Excel, only that time I follow priority wise. Okay, I first put high priority, then put a low priority, and then I follow first in first out manner. In this same scenario, in a queue, a priority queue, while inserting a data, when inserting a data, that time only it insert a priority wise. Okay, or it insert a ascending order wise. Okay, time retrieving, that time it will follow first in first out manner only. Okay, and then we have a second DQ. DQ is the interface, and this one is introduced in a 1.6 version. The Java DQ interface present in a java.util package represent a double-ended queue. DQ represent a double-ended queue, meaning a queue where you can add and remove element from both sides. You can add element from front, you can add element from rear. Okay, there is no matter because this one is a double-ended queue. This have a two ending point, and a simple queue have a single ending point, and this have a two ending point. Here we can store duplicate and null value. There is no restriction. Here we can simply store duplicate, here we can store a null value. Here you can see this example. Here we can simply create an object by using a linked list and array DQ. These two are implementation classes for a DQ. And here we have some methods: add last, add first, offer first, offer last. Okay, these all methods present inside a DQ interface. Then third one we have a blocking queue. This one is also interface. Blocking queue introduced in a Java 1.5 version. It thread safe. At a time it allow only one element can store or can retrieve, because this one is a blocking queue and it's a thread safe. That's why it's a block. it only allow one thread to access, it block other thread. Okay, that's why it's called a blocking queue. This thread say block multiple access point, it allow duplicate, but we can't store a null value. Here also we can't store a null value. Blocking queue has some implementation classes. You can see these implementation classes: linked blocking queue, then array blocking queue, then priority blocking queue. Okay, here you can see these three things we saw. The other thing also available in a queue, but we will discuss only these three things because the queue is a huge part and we can't cover this part in a few videos. Okay, so that's why we will discuss only important thing. First, let's discuss one by one this practically. I'll simply open Eclipse and we will discuss first priority queue. Okay, let's open and I'll simply create a one class. Let's create here class with the name part87, and here we create a main method. Let's create here main method. Then first we create a priority queue. Okay, let's first check what inside a queue. Okay, let's check how many methods present inside a queue. I'll simply open a declaration, and here you can see add, offer, remove, pull, element, peek. These all method present inside a queue interface. Okay. Okay, here first we discuss a priority queue. Let's create a priority queue object, priority queue, and here we pass a string. Here we create a generic. Okay, then pq, then equal to new priority, and here you can see priority queue has few constructor. You can see this one is the default constructor. Then here we can pass any other collection object. Then here we pass the initial capacity, and here we pass the other priority queue object, and here we sorted a set all this constructor present inside a for priority queue, for creating a priority queue. Okay, let's create a default priority queue object, and I'll show what present inside a priority queue first. Let's open this and let's check how many methods present inside a priority queue. You can see this all constructor present priority queue, then priority queue comparator. Here we can simply pass a comparator. Okay, then here you can see all this constructor. Then here we have a few methods: add, offer, peek. This here you can see this all method came from parent interface. Okay, here you can see all this method present inside this priority queue class. Okay, let's save this, and I'll simply store a few record pq dot add, and let's add here quickly few record a, then pq dot add, here we add b, then pq dot add, here we add again d. Okay, I'll show one thing here, pq dot add, okay, pq dot add. Okay, here we add x, and let's see here instead of a, here we add f. Okay, not a, and here we add a. So now let's print this object. I'll simply print this whole object pq, and here you can see here we get output a, f, b, x. Only the insertion time it follow ascending order. By default it follow ascending order, and in this way it can consider this one is a high priority, then this one is a low, then this one, then this one. It will simply store ascending order, and it will print in that order. Okay, now here we discuss a priority queue. Let's discuss a second point, dq. Let's create this dq object. I'll simply create a dq object. Okay, let's create this dq object. This dq present inside a util package. Okay, let's pass here a string, and let's create this one is also generic, then dq equal to new, and here you can see here we have this implemented classes linked list and array dq. Okay, let's use a linked list. Okay, linked list, and here you can see here we can simply add a record using a object dq dot add. Here first we add Okay, first we add a. Okay, then here we have a few more method. dq dot add first. Okay, I want to add first a. Then I want to add dq dot add last. Okay, then again add a few things. Okay, then again add last xx. Okay, then I'll simply use one more time dq dot add, and here we add a v. Okay, now here you can see here we can add element from first, here we can add element from last, because here we have a double ending position. Okay, here we can end our point to rear or front. Okay, here this two ending point, that's why double ending, dq means double ending point. Okay, so let's save this and print this object 𝑠𝒂𝒄 dq, and let's save, run this, and here you can see this first we add a, then we call this method add first. Okay, then this one add first, then this we add xx, we add last. This method we can perform operation at the front or a rear, or also we can remove element. Okay, you can see dq dot remove first, remove last. Okay, we can, if you want to remove first element, then we will simply call this remove first, and let's save and run this, and you can see this a is removed because here we call a remove first. Then we have a dq dot remove last. Okay, let's call this remove last, and here you can see this last one is also removed v, this one also removed. Okay, now here we can perform this all method, we can use this all method, and we can perform operation for both side, rear or front. We can add, we can remove from both side. That's why we call here dq, and dq is the interface, and that's why we have to use this implemented classes. We have a linked list and array dq, these are implemented classes. Then finally we have a blocking queue. Okay, let's create this blocking queue. This blocking queue is also interface, and this blocking queue have several implementation classes: linked blocking queue, array blocking queue, and priority blocking queue. Okay, let's create this blocking queue object. Okay, I'll simply create here and create here bq equal to new. Here we have this link blocking queue, array blocking queue, and priority blocking queue. Okay, let's create here linked blocking queue. Okay, you can see this linked blocking queue. Let's create this linked blocking queue object and add here some bq. Okay, let's add here bq dot add, and here we can add record, then again bq dot add, here add b. Okay, then print this blocking queue bq. Okay, directly print 𝑠𝒂𝒄, then bq, and let's save this, run this. Here you can see, here we get data. Now first discuss what inside this dq. Okay, what internal operation, what is internal code in this dq. Okay, here you can see this one is a dq, and this introduced in a 1.6, and here we have a few methods. Okay, let's check those methods. Here you can see add first, add last, offer first, offer last, then remove first, remove last, and this all method present inside this dq. This first and last all method present inside dq, because this one is a double ending queue. Then we have this second one, linked list. Okay, let's see this linked list class extend abstract sequential list. Okay, then here some implemented interface list dq and clonable and serializable. This clonable and serializable is implemented for all collection child classes. Okay, collection, whatever collection inside a collection, whatever classes interfaces available, those all implemented these two things, clonable and serializable. Okay, then let's check this blocking queue. Okay, I'll simply open this implementation code. Okay, here BlockingQueue is the interface, and this BlockingQueue directly extending this queue interface. Okay, this BlockingQueue introduced in a 1.5, and let's check how many methods present inside this BlockingQueue. Here you can see this little bit arrow icon means this method came from parent interface. Okay, this put one is the BlockingQueue own method. Then this offer, take, pull, remaining, these few methods, this BlockingQueue own method. Other than this all arrow method came from parent interface. Okay, then here we have this linked BlockingQueue. Okay, let's open this linked BlockingQueue. Here you can see this linked BlockingQueue. This linked BlockingQueue extend this abstract queue. Okay, let's open declaration this abstract queue. This abstract queue extend this abstract collection. Okay, let's open this abstract collection. This abstract collection implement this collection interface. Okay, here we check a linked BlockingQueue. Now let's check this array BlockingQueue. Array BlockingQueue. Okay, here you can see this array BlockingQueue don't have any default constructor. Here we have to pass at least initial capacity value. Then here three constructor available, but here don't have a default constructor. If we create using an array BlockingQueue class, if you create any object, then we have to pass this capacity. Okay, initial capacity. I'll simply pass here 20 initial capacity. Let's save and run this. Here get a value. Now let's try here. I'll simply bq, then add here. I'll try to add here null value. Okay, now let's check is it acceptable or not. You can see this BlockingQueue don't accept null value. Okay, this BlockingQueue not accept null value. Then we have a last priority BlockingQueue. Okay, let's create here priority BlockingQueue. Priority BlockingQueue provide a default constructor. Then we can pass a collection. Then we can pass a initial capacity, and finally initial capacity and comparator. Okay, so let's add this first one, priority with the default, and remove this. Okay, I'll simply remove this, and you can see, let's save this and run this, and you can see here we get a proper value. If I add this null, okay, then what happen? Again it will throw error null pointer exception. Okay, this BlockingQueue not accept a null. Let's check dq accept or not. Okay, dq accept duplicate, and let's check dq dot add, and let's pass here a null value. Okay, let's run this and check this dq happily accept null value. Now let's check this priority queue accept or not. Okay, let's do here pq dot add, and here we pass a null, and let's save and run this, and here you can see here we get a error because this priority queue comparing element, this second one dq not comparing element, this BlockingQueue also comparing element. That's why they required they don't allow null, because if we compare any value with a null, then it will throw null pointer exception. Okay, here we discuss a basic overview of queue, and here we discuss a few classes and interfaces of queue. Okay, we will see next topic in the next video. Till that, bye bye.